Hello and welcome back to Code. My name is John and in this video we will be talking about recursion. Recursion is a programming technique where a function calls itself to solve a problem by breaking it down into smaller instances of the same problem. Recursion requires careful consideration of base cases to prevent infinite loops. Understanding recursion is fundamental for mastering many programming concepts and algorithms. So without further ado, let's see recursive function in action. But before we talk about recursive function, let's see what is a function in JavaScript. Functions are one of the fundamental building blocks in JavaScript. A function is a set of statements that performs a task or calculates a value. To use a function, you must define it somewhere in the scope from which you wish to call it. A function definition, or also called a function declaration or a function statement, consists of the function keyword followed by the name of the function, a list of parameters to the function enclosed in parentheses and separated by commas, and the JavaScript statements that define the function enclosed in curly braces. For example, the following code defines a simple function named square. Function square takes one parameter called number. The function consists of one statement and that says to return the parameter of that function multiplied by itself. The return statement specifies the value returned by the function, which is return number into number. Parameters are essentially passed to the function by value. So if the code within the body of a function assigns a completely new value to a parameter, the change is not reflected globally or in the code which called that function. But if you pass an object as a parameter, whatever change you have done to that object property, that change is visible outside the function. So if you want to change the value globally, you pass the parameter as an object. When you pass an array as a parameter, if the function changes any of the array's value, that change is visible outside the function because array is also an object in JavaScript. Functions can also be created using function expression. Such a function expression can be anonymous or can have a name. If it does not have a name, it is called anonymous function. For example, let's see how we can change the previous square function into function expression. So here you can see the same square function represented as a function expression. Here this function doesn't have a name. So such functions can be called anonymous functions. And this function is assigned to the variable square. So if we run this function, you can see we get the value. We can also give a name to this function and represent it as a named function expression. For example, let's see this factorial function. So in this factorial function, we actually need to call this function repeatedly inside the function. In such cases, we can also give a name to the function. For example, here we have given fact as the name of this function. We can call this function using factorial, and also we can call this function using the fact inside that function. So that means providing a name allows the function to refer to itself. Function expressions are also convenient when passing a function as an argument to another function. For example, let's see this function. Function map receive a function as well as an array of numbers. So Q is the function that is going to be passed to the map function. So map function basically iterates all the elements in the array and call the function passed to it, and the results are stored in the results array, and the results array is returned. A function can refer to and call itself in three ways. One is using the function's name. The second way is using an in-scope variable that refers to the function. And the third way is using arguments.call. So arguments.call is currently deprecated in many browsers and it is not recommended to be used. For example, let's see this function expression. Here, this function has the name called bar. So you can use that function name to call that function. and also the arguments.callee. Arguments are a special array-like object accessible inside function that contain the value of the arguments passed to that function. And we can also use the in-scope variable to refer the function. Here the in-scope variable is foo. And remember this foo has global scope. The function bar can only be accessed inside the block. This is because it is not available outside this scope. Now let's see what is recursion. Recursion is a technique where the function calls itself, breaking it down into smaller subproblems. There are two considerations for any recursive function. First one is you should have a condition to exit from the recursive call. So recursive function will call itself until that condition is met. Second consideration is the recursion is limited by stack size. We know that whenever we call a function, our function is added to the call stack. So if we call the function recursively, all those functions are added to the call stack. And if it exceeds the stack size, it will throw the error maximum size has been exceeded. For example, in JavaScript, you can see the maximum call stack size using this function. A recursive function has two important code blocks. First one is the base case block where it ends the recursion, and the second one is recursive case block which resumes the recursion. A recursive function calls itself until the base condition is met. In some ways, recursion is analogous to a loop. Both executes the same code multiple times and both require a condition. For example, let's see a while loop. This while loop will do the stuff, or it will call the function do stuff until the value of x is 10. So if we try to run this function, we will get the value 1, 2, 3, 4, 5, 6, 7, 8 printed up to 9. Now the same can be done using recursion by calling the doStuff function inside that function. So if you notice the two blocks that we learned earlier, this if condition will be the base case block where it ends the recursion. So it says that if x is greater than or equal to 10, you should return from the function. And this here is the recursive block where it resumes the recursion. So it will call the do stuff until x is greater than or equal to 10, and it will print the result of each x. We will call this function by using the initial value 0, and let's see the output by running the code. The same while loop output has been printed using the recursive block. Now let's see what is a recurrence relation of a recursive function. And later we will also analyze the time complexity of a popular sorting algorithm called merge sort. A recurrence relation is a mathematical equation where any term is defined using its previous step. We can use recurrence relation to analyze the time complexity of recursive algorithms. Mathematically, we can say that if the time complexity function of input size n is t of n, then the time complexity of smaller subproblems will be defined by the same function with the subproblem's input size. That is, t of n equal to t of input size of first subproblem plus t of input size of second subproblem plus etc. until t of input size of kth subproblem plus the time complexity of additional operation other than recursive calls. So to find the time complexity of a recursive algorithm, there are three steps that are followed. First one is identify the input size of larger and smaller subproblems. Then write the recurrence relation for the time complexity. Then solve those recurrence relation to get the time complexity using recursion tree or any master theorem approach. So now let's analyze the merge sort algorithm. Merge sort is a recursive algorithm that continuously splits the array in half until it cannot be further divided. That is, the array has only one element left. And we can say that an array with one element is always sorted, hypothetically. Then the sorted subarrays are merged back into one sorted array. Let's say we have to sort n size array using merge sort. Let the time complexity be T of n, where n is the input size. We can then start with C into n at the ground level, which represents the cost of additional operations at the ground level of the recursion tree. Now the left and right children of the root node have the time complexities of T of n by 2 because the n is divided by, or the input size is divided by half on each level of the recursion tree. So at the second level, there are two nodes of size n by 2, and the cost of the additional operations at each node is C into n by 2, which is again C into n by 2 plus C into n by 2, which is C into n for the second level nodes combined. Similarly, if we move to the below levels, we can see the total complexities remains the same, C into n. That is, on level 3, we can say we have 4 nodes with time complexities of T of n by 4, which is half of the input size of the second level. So total time complexity will be C into n by 4 plus C into n by 4 plus C into n by 4 plus C into n by 4, which is equal to C into n for the third level nodes combined. In general, we can say that at any level I, total complexity is 2 raised to I into C into n by 2 raised to I, which is always C into n. Here the tree will have log n levels because at each level the input size is divided by 2, and it continues until the last level has input size 1, making it logarithmic. So in the last video we have mentioned about the logarithmic sequence. So total time complexities will be the addition of all time complexities in each level, meaning T of n equal to C into n into log n. After ignoring the constants, we can say that T of n is equal to n into log n. So the bingo notation of the merge sort is of n log n. Now let's see how we can implement merge sort using JavaScript. So let's write a function merge sort, which accepts a list of array of length n. Now we need to slice this list into two halves. So for that we can first find the midpoint. You can say const mid equal to math or floor is to length by 2. So this will be our midpoint or mid index. Now let's say our first sub list will be list dot slice from 0 to our midpoint, the mid index. Now and our second sub list will be from mid to the last element of the list. In merge sort, we know that we will create the sublist until the size of the list is 1. So our base condition would be if the list size is 1, then we will return the list. So we can write our base condition as if list dot length is less than or equal to 1, we will return the list. So this will be our base condition. So we need to create more sublists until the length of the sublist is 1. So we can say merged sub list one or const but sub list one will be equal to merge sort the sub list one. Similarly, const merge sub list two will be equal to merge sort sub list two. So now we have created all the sublists until sublist length is 1. Now we need a function to merge all the sublists back. So we can say return merge. Merge is a function that we need to write, and we can give the two lists as the list to be merged back. So we need to write another function where all these sublists will be merged back. So we can say function merge. It will accept two lists, which is list 1 and list 2. And here we will be needing a results array to store the merged list. And let's add two pointers so that each list can be iterated separately. So I equal to 0 and ij equal to 0. So we initialize two pointers so that each list can be iterated separately. So we'll write a while, and here we will try to take all items from list 1 as well as list 2. So our condition would be when I is less than list 1 dot length as well as j is less than list 2 dot length. So if this condition satisfied, we will need to push the whatever smallest number in either of the list. So results dot push, we need to check if list 1 of I is less than list 2 of j. If that is the case, we will say use the number from the list 1 of I. Then also increment the I. Similarly, if the condition is false, we will say take the number from list 2 of j and also increment j. So this I plus plus and j plus plus literally means use the value of I, then increment the value of I for the next iteration. So it will always take the value of I first, then increments the value of I. So now we have used the value of list 1 and list 2 until I and j respectively. So what if list 1 was smaller in length than list 2? There will be some items pending in list 2 to be iterated. So we need to concatenate that with the results array. So we can say results dot concat. If there is some pending values in list 1, we can say list 1 dot slice the I. So it will take values greater than I. And similarly for list 2, we will say list 2 dot slice take the values which is greater than current j. So now the results will have all the values that is being in list 1 and list 2 merged together. Now we can return these results. So this will be the implementation of merge sort. So now let's just check out whether it is working or not. So let's write a console.log merge sort. So we need to sort this array. So now let's just run the code and see whether it is working. Now you can see the array is sorted. So that's how we implement merge sort using JavaScript. So in this video, we mainly talked about recursion, its properties, and we also did a sample analysis of merge sort, which is a recursive algorithm. In the next video, we will talk about dynamic and static arrays and linked list, which are the basic of many complex data structures. Until then, thank you for watching. See you in the next video. Bye.